Welcome back to the Quantum Slumber. Tonight, we are stepping into one of the most disturbing ideas in modern physics. Not fantasy, not mysticism, not a metaphor people use to feel better about death. Something colder than that. There are branches of reality where tonight never happened for you, where one tiny event unfolded differently, where one quantum outcome went the other way, where a microscopic chain of causes, far too small for you to ever notice, ended your story before this moment could begin. You are not in those branches. You cannot be. Because you are here, you are listening, you are still conscious on this side of reality, and if one of the most serious interpretations of quantum mechanics is true, that may not be luck, it may be law. Tonight, we are going into the strange territory where physics meets death, where the mathematics of the universe seems to suggest that, from your own point of view, you may never be able to witness your own end. We will follow this idea through quantum mechanics, through the many worlds interpretation, through the life of Hugh Everett III, and into a question so unsettling that even many physicists prefer not to linger there for too long. What if death looks very different from the inside than it does from the outside? And if you enjoy these slow nighttime journeys into quantum physics, consciousness, and the deeper mysteries of reality, take a moment to like the video, subscribe to the channel, and leave a comment telling me what topic you want to explore next. Now, let us begin with something simple. You woke up today and assumed that was ordinary, but surviving a single day may already be stranger than anyone wants to admit. You woke up this morning and did what people always do. You opened your eyes, you reached for your phone, or stared at the ceiling for a few quiet seconds, or turned toward the edge of the bed and let your feet find the floor. Nothing about it felt extraordinary. It felt routine, familiar, small. That is how survival usually feels. It does not announce itself. It does not arrive with music. It does not pause in the doorway and wait for gratitude. It simply passes through the body as ordinary life. And because it feels ordinary, we rarely notice how much had to go right for it to happen at all. The heart had to keep its rhythm through the night. The lungs had to continue their patient exchange. Blood had to keep moving through vessels no wider than a human hair. Cells had to repair what could be repaired, contain what could be contained, discard what could not be trusted, and repeat that labor in silence while you slept. Even now, while you are listening, your body is performing an absurd number of negotiations at once. Electrical signals race through nerves. Proteins fold into the shapes they need. Immune cells patrol for damage. Tiny molecular machines copy, cut, move, build, and destroy, with a precision that would look almost supernatural if it were not happening inside you every second of your life. Most of the time, the machinery holds, but not because the world is stable, not because the body is invulnerable, and not because the margin between continuing and not continuing is as wide as it feels. It is usually much thinner than that. As you slept, particles from deep space were passing through the atmosphere above you. Some of them were born in violent places unimaginably far away. Exploding stars, extreme magnetic fields, collisions more energetic than anything human hands can easily make. By the time they reach Earth, many have broken into showers of secondary particles, and some of those pass through buildings, through walls, through skin, through bone, through you. This sounds dramatic, but it is not rare. It is happening all the time. Most of these particles pass through harmlessly. They leave no sensation, no warning, no mark you can feel. But every now and then, in just the wrong place, a particle can strike a molecule, disturb an atom, nick a strand of DNA, alter a tiny piece of chemistry so slightly that the event would seem too small to matter. Usually, the body repairs the damage. Usually, that word governs more of your life than you feel. Usually, the cell catches the error. Usually, the mutation goes nowhere. Usually, the blood clot dissolves instead of traveling. Usually, the vessel holds. Usually, the rhythm returns. Usually, the driver in the next lane brakes in time. Usually, the stair is where your foot expects it to be. Usually, the artery does not rupture. Usually, the signal crosses the synapse the way it needs to. Usually the breath arrives. You live inside a cathedral of usually. And because it holds day after day, year after year, the mind begins to treat it as certainty. But certainty is not what you are standing on. Think about an ordinary drive, a green light, a turn across traffic, a merge onto a highway, a patch of rain, a text message lighting up in another car, a driver looking down for 1 second, a tire with slightly less pressure than it should have, a moment of distraction, a delayed reaction by half a heartbeat. It does not take much. It never takes much. The line between an uneventful afternoon and a life-ending event is often drawn in distances too small for your intuition to respect. Or think even smaller, a single weakened vessel wall, a tiny piece of plaque that holds for another month instead of breaking free today, a single immune cell that identifies the wrong thing just late enough to matter, a molecular repair process that succeeds where it might have failed. At the scale where life is actually maintained, the drama is almost invisible. No thunder, no prophecy. Just a trillion microscopic decisions made without asking you. And yet those decisions are the real architecture of your survival. The strange thing is that the brain is not designed to feel this clearly. If you were fully aware of how narrow the margins often are, you would not be calmer. You would be paralyzed. So, consciousness gives you a cleaner story. It edits, it smooths, it tells you that life is stable enough to move through, that tomorrow is likely enough to plan for, that your body is trustworthy enough to ignore most of the time. That simplification is useful. It may even be necessary. But it is not the deepest description of what is happening. At the deepest level, your continued existence is not a single grand victory. It is an endless accumulation of tiny survivals, quiet survivals, chemical survivals, statistical survivals, the kind that never feel cinematic because they happen beneath awareness, beneath language, beneath the level where the self usually places meaning. You did not survive today because of one heroic act. You survived because countless things did not go wrong at once. Because the processes inside you remained coordinated for a few hours more. Because the world, which is full of collisions and hazards and blind mechanical indifference, allowed a narrow and temporary order to continue wearing your name. And that may be the unsettling truth underneath ordinary life. What you call a normal day is not proof that reality is safe. It may simply be proof that you are used to how quietly danger works. The coffee on the counter, the air in the room, the crossing of a street, the rising and falling of your chest. They feel simple only because they happen so often. But repetition is not the same thing as guarantee. Familiarity is not the same thing as security. The fact that something happened again today does not mean it had to. It only means that, out of all the ways this day could have gone, you are here inside the version where it continued. And once you begin to see life that way, once you begin to feel how much of survival rests on tiny hidden margins, the idea that some people seem to outlive impossible odds starts to feel a little less like mythology and a little more like a question. There are people whose survival feels less like biography and more like an insult to probability. Not because they were reckless, not because they were blessed, not because physics bent itself around them in some theatrical way, but because when you place the facts side by side, the sequence begins to look almost unreal. The numbers do not stop making sense exactly, but they stop feeling human. They become too thin, too sharp, too absurd for intuition to hold comfortably. One of the strangest examples was Roy Sullivan, a park ranger in Shenandoah National Park in Virginia. Between 1942 and 1977, he was struck by lightning 7 times. Not rumors, not close calls, direct strikes. 7. The first burned his leg. Another hit him while he was driving and scorched his eyebrows. Another set his hair on fire. Others came in his yard, in the park, in places where a single strike would already feel like the kind of event a person tells for the rest of their life. Sullivan survived all 7. A single lightning strike is already the sort of thing most people would prefer to keep at the level of abstract possibility. But 7 direct encounters with that much voltage, that much heat, that much violent atmospheric force begins to feel like the universe circling one name over and over again. The odds become difficult to express in an emotionally meaningful way. Once the number gets small enough, the mind stops distinguishing between unlikely and impossible. It files both under the same category. That should not happen. And yet it did. Then there was Julian Kupska. Christmas Eve, 1971, a flight over Peru, a thunderstorm, turbulence, a bolt of lightning. The aircraft broke apart over the Amazon rainforest. 91 people were on board. 90 died. Kupska, who was 17 years old, fell from the sky still strapped to her row of seats and somehow lived. Even now, the sentence sounds wrong. A person falling from an aircraft thousands of feet above the rainforest and surviving should not fit cleanly into the world as we understand it. But it happened. She crashed through the canopy, landed in the dense jungle below, and woke with injuries that were serious but not fatal. A broken collarbone, cuts, swelling, shock. And then, instead of dying in the days that followed, she did something even stranger. She walked. For 11 days she moved through the Amazon, following water the way her father had taught her. She was alone. Insects entered her wounds. She had almost no food. She passed bodies. She kept going. Eventually she found help and was carried to safety. People later tried to explain it, and of course they did, because the human mind hates an event that sounds like a miracle but insists on being historical fact. The row of seats may have acted like a crude parachute. The canopy may have distributed the force of impact. Her angle, her posture, the weather, the density of foliage, the exact timing of everything may have aligned in the single narrow way required to keep her alive. That is what explanation looks like when the event itself feels intolerably improbable. We begin stacking conditions on top of conditions, building a tower of tiny necessities until survival seems less like one thing that happened and more like a corridor so narrow it should have closed before anyone got through it. And still, she did. Then there was Vesna Vulovic, a flight attendant aboard Jait Flight 367 in 1972. The aircraft broke apart at cruising altitude over what was then Czechoslovakia. Everyone else on board died. Vulovic did not. She fell more than 6 miles without a parachute and survived. She suffered massive injuries, a fractured skull, broken legs, damaged vertebrae, temporary paralysis, but she lived. That survival carries the same eerie quality as the others. It was not graceful. It was not clean. It was not a story about escaping untouched. It was a story about enduring far beyond where a normal sense of odds says the line should have ended. A snow-covered hillside, a section of fuselage, the angle of impact, the fact that a medic happened to be nearby. Again, the explanation comes in a chain of specifics so exact that each one feels like a lock clicking open at just the right moment. Lightning 7 times, a fall through a rainforest from a shattered plane, a 6-mile plunge from the sky. These stories stay with people because they disturb something deeper than simple curiosity. They make ordinary probability feel incomplete, or at least emotionally inadequate. We know intellectually that rare things happen. We know someone must occupy the thin edge of the bell curve. We know statistics do not forbid extreme outcomes. But knowledge is not the same thing as comfort. When survival becomes this concentrated, this repeated, this surreal, we begin to feel that unlikely is no longer doing enough work. It is important to be careful here. These cases are not proof of quantum immortality. They are not evidence that some hidden branch selection mechanism can be seen directly in everyday life. To say that would be too crude, too eager, too careless with the difference between a haunting idea and a scientific demonstration. Extreme survivals happen in a single worldview too. Probability, given enough time and enough people, will eventually produce events that sound almost fictional when told aloud. But that caution does not erase the feeling these stories produce. They sharpen it, Because once you accept that life is already balanced on margins thinner than it appears, these impossible survivors begin to look less like cheerful exceptions and more like windows. Not windows into certainty, not windows into proof, just windows into the unsettling fact that survival is not always intuitive from the inside. A life can continue through conditions that seem too violent, too random, too precisely misaligned to permit continuation. And yet, the continuation happens anyway. From the outside, we call it luck, or chance, or 1 in a million. From the inside, it feels very different. From the inside, there is simply still a point of view, still a body carrying awareness forward, still another morning, still another breath, still another sentence after the sentence that should have been the last one. That difference matters. Because the unsettling idea waiting underneath all of this is not merely that some people survive impossible things. It is that if reality is built in a certain way, then impossible survival may not always be a miracle at all. It may be what it looks like, when consciousness can only ever notice the branches where it continues. In 1957, a 26-year-old graduate student at Princeton proposed an idea that did not merely adjust quantum mechanics. It changed the emotional meaning of reality. His name was Hugh Everett III. At the time, quantum mechanics already worked. That is what made the problem so strange. The equations predicted experiments with extraordinary accuracy. They gave the right numbers. They described atoms, light, particles, energy levels, radioactive decay. Again and again, the theory succeeded. But under that success was a quiet fracture that many physicists had learned to live with and stop staring at too hard. The fracture was measurement. Before a quantum system is measured, it can exist in what physicists call a superposition, a combination of different possible outcomes at once. A particle can be in a state corresponding to more than one result. A photon aimed at a device can be described as taking multiple possible paths. The mathematics permits this easily. In fact, the mathematics demands it. But when a measurement is made, when an instrument records a result, when an observer looks, only one outcome appears. One result, one reading, one world. The standard answer, taught for decades under the Copenhagen interpretation, was that the wave function collapses. Before measurement, many possibilities exist in superposition. At measurement, that spread of possibilities reduces to a single actual event. The photon is found here, not there. The spin is up, not down. The atom decayed, or it did not. The mathematics gives probabilities, and reality selects one. For many physicists, that was enough. It matched experience. It preserved the single world of common sense. But to Everett, something about it felt deeply artificial. The collapse was not derived from the core equation. It was inserted, added, a rule placed on top of the mathematics rather than emerging from it. And Everett asked a dangerous question. What if nothing collapses at all? Not sometimes, not in special cases, not when consciousness arrives, not when an instrument clicks, never. What if the Schrödinger equation, the central equation of quantum mechanics, tells the truth continuously and without exception? That question sounds technical at first, but if you let it sit for a moment, it becomes almost unbearable. Because if the wave function never collapses, then the possibilities do not disappear when a measurement happens. They continue, all of them. The universe does not choose one and erase the rest. It carries every allowed outcome forward. A photon approaches a beam splitter, a device that sends light one way or another. Under the usual story, the photon has a 50-50 chance of going left or right, and when the result is measured, one path becomes real. Everett's idea was colder and more radical. The photon goes left in one branch of reality and right in another. Both outcomes are retained inside the total quantum state. Both are real. Both continue. The same logic applies to spin. Measure the spin of an electron along a chosen axis, and the result may be up or down. Under collapse, one outcome appears and the other ceases to matter. Under Everett's view, the measurement does not destroy one possibility in favor of the other. It correlates the measuring device and eventually the observer with both. In one branch, the device records spin up. In another, it records spin down. In one branch, the observer sees one result. In another, the observer sees the other. This was the heart of what Everett called the relative state formulation. The phrase sounds dry, almost polite, but buried inside it was an assault on the ordinary idea that there is one final outcome shared by everyone. Everett argued that the state of a system is always relative to the state of whatever has become correlated with it. There is no need for a magical collapse, no need for the observer to stand outside the physics, no need to treat measurement as a sacred event where mathematics pauses and reality suddenly becomes singular. The observer is not special. That point mattered enormously. In older ways of speaking about quantum mechanics, the observer seemed to occupy a privileged place, almost an embarrassing one. The act of observation looked as though it might sit somehow outside the formal physical story, as if mind or measurement had to intervene from above and force the world to decide what it was. Everett rejected that. The observer, in his view, is just another physical system, a brain, a body, a measuring apparatus made of atoms, becoming entangled with other atoms. Nothing supernatural happens. Nothing steps in from outside. The equations keep going, and if they keep going, then the branching is not rare. It is not a dramatic event reserved for laboratories. It is woven into the fabric of every quantum interaction. Every time the physics permits multiple outcomes, the universal wave function carries them onward in the correlated structure, not just in beam splitters and spin measurements, but everywhere, in radiation, in chemistry, in stars, in matter, in the smallest transitions underlying the visible world. That is where the idea stops feeling like interpretation and starts feeling like vertigo. Because the implication is no longer limited to particles in isolation, it extends to everything: the lab, the observer, the room, the earth, the sky above the building, the history leading to the measurement, and the futures flowing out of it. The total state of reality becomes a branching structure of outcomes, each internally consistent, each real relative to the observers inside it. Bryce DeWitt later gave this picture the name that would make it famous: the many worlds interpretation. The label is memorable, but it can also mislead. It sounds as though new universes are being manufactured like bubbles peeling off from a machine. Everett's actual point was more precise. There is one universal wave function evolving according to quantum law. What we call many worlds are the effectively separate branches inside that total structure, branches that no longer interfere with each other once they become sufficiently entangled with the environment. You do not feel the split. You do not hear it happen. From the inside, each observer experiences one smooth line of reality, one result, one memory, one apparent world. That is what makes the theory so unsettling. It preserves ordinary experience while removing the comforting assumption that ordinary experience is the whole thing. And once that idea is allowed into the room, death begins to look different. Not because the body becomes invincible, not because the theory promises salvation, but because if all allowed outcomes continue, then outcomes involving survival continue too. The consequences of that are not yet the point, not fully, but they are already there, waiting just beneath the surface of the mathematics. Everett did not merely offer a new answer to an old technical puzzle. He removed collapse, removed the privileged observer, and replaced a single finished reality with a branching totality in which every permitted result remains inside the structure of the real. It was elegant, it was severe, and once you see what it implies, the familiar idea of death begins to lose its old simplicity. Imagine a device built to answer a question that no laboratory can safely ask. Not a poetic question, not a religious one, a brutally mechanical one, a question with metal in it, a question with probability in it, a question that becomes horrifying the moment you realize only one person could ever know the answer. The setup is simple enough to describe in a few lines. You place a quantum random number generator in front of a weapon. The generator measures a microscopic event, something genuinely quantum, not a coin toss, not a hidden classical process, not a computer pretending to be random. A particle's spin, for example. If the result is one value, the weapon clicks harmlessly. If the result is the other, it fires. 50-50. Pure quantum uncertainty. No intuition helps you here, because the terror of the thought experiment comes from how clean it is. The machine does not care about courage, personality, willpower, regret, or whether the person sitting in the chair has a family waiting at home. It cares only about one branching event at the smallest scale and a macroscopic consequence immediately attached to it. Click or bang, alive or dead, one measurement, one trigger pull. This idea is usually associated with Max Tegmark, who formalized it in the late 1990s and gave it the name that made it impossible to forget: quantum suicide. But the deeper logic reaches back to Hugh Everett's picture of reality, because the entire experiment only becomes meaningful if the wave function never collapses. Under the Copenhagen interpretation, the meaning is obvious. The quantum state gives probabilities. The measurement occurs. One outcome becomes actual. If the lethal outcome occurs, the experiment ends permanently. Pull the trigger once and there is a 50% chance you die. Pull it 10 times, and the odds of surviving all 10 are tiny. Pull it 100 times, and the number becomes so small that ordinary language starts to fail. Copenhagen leaves no real mystery here. It is grisly, but mathematically straightforward. The apparatus measures. The wave function collapses. One result is realized. If that result is death, then death is simply what happened. But under many worlds, the same apparatus tells a completely different story. The particle is measured. The universal wave function evolves. One branch contains the click. Another contains the gunshot. One branch contains the continuing observer. Another contains the body without one. Nothing collapses. Nothing gets erased. The measurement does not select a single world and destroy the rest. It correlates observer, device, and outcome across multiple branches that now continue separately. That is where the thought experiment stops being merely dark and becomes almost impossible to sit with calmly. Because from the outside, the statistics still look normal. That part is crucial. If a friend watches you perform the experiment, they do not see a miracle. They see exactly what standard probabilities predict. At some point, likely very early, the lethal result occurs. The body falls, the room becomes silent, the experiment is over. But from the inside, from the point of view of the person in the chair, something very different seems to happen. You can only be conscious in the branches where your brain remains physically able to support consciousness. You do not experience the branches in which you are dead, because there is no subject left there to register anything. Awareness cannot look out from a destroyed nervous system and take notes. It cannot say, so this is non-existence. There is no one there to say it. So, if the branching picture is correct, then after the first trigger pull, there are branches where you are gone and branches where you hear only a click. Subjectively, the click is the only thing you can ever experience. Pull the trigger again. Again, branching. Again, at least one branch ends. Again, at least one continues. Again, the only branch that contains a conscious point of view is the branch where the weapon did not fire. Again, again, again. Seen from outside, this is not immortality. It is a tragic experiment with a predictable outcome. Seen from inside, it begins to resemble something far more disturbing. A sequence in which the lethal result never arrives in experience, no matter how many times physics permits it elsewhere. That is the core of quantum immortality. Not the claim that bodies cannot die. Not the claim that all versions of you survive. Not the childish fantasy that the universe protects a favored observer from harm. The claim is narrower, colder, and in some ways worse. It says that first-person awareness may be unable to encounter its own absence. If there is always at least one surviving branch, then consciousness seems condemned to continue only in those branches. You do not witness the worlds where you died. You only inhabit the worlds where you did not. This is why the thought experiment feels so singularly toxic. It is not merely about probability, it is about perspective. It creates a split between third-person physics and first-person experience that no ordinary intuition is prepared for. Tegmark pointed out the most disturbing feature himself. The experiment can only ever convince the person performing it. No one else gets the evidence. No paper can be written that proves the point to the scientific community, because in the overwhelming majority of branches visible to everyone else, the experiment ends in death. Colleagues do not receive your triumphant report. They receive news of a catastrophe. They bury you. They conclude nothing useful has been demonstrated. Only the surviving observer seems to acquire information, and even that information cannot escape the branch. It is a perfect private result, a kind of anti-science, an observation that matters infinitely to one observer, and almost not at all to anyone else, because no interbranch communication exists to share it. The evidence, if it exists, is trapped inside the only perspective capable of receiving it. This is one reason the thought experiment has such a grim reputation, even among physicists who enjoy pushing ideas to their logical extremes. It is not just morbid, it attacks the social structure of science itself. Science depends on public results, repeatability, shared evidence, consensus built from common observation. Quantum suicide, if taken seriously, offers none of that. It offers only a private corridor through branching reality and a result that dies with the person who observes it. There is another reason physicists recoil from it. The experiment is too clean. Real death is usually not like that. Outside of science fiction and deliberately engineered scenarios, dying is not a crisp binary event with a single quantum trigger attached to a single immediate outcome. It is often gradual. It involves trauma, fading, partial injury, altered awareness, medical intervention, bodily failure unfolding over time. Consciousness dims, it fragments, it lingers. The world of actual mortality is messy in ways that thought experiments are designed to strip away. Quantum suicide works only because it forces reality into a narrow logical shape. One microscopic random event, one macroscopic life or death consequence, no middle ground. That artificial purity is what makes the conclusion so hard to ignore. If you grant the setup, and if you grant many worlds, and if you grant that awareness can only occur in branches where the physical substrate of awareness still functions, then the logic seems to tighten around you, not metaphorically, mechanically. You sit in the chair, the device measures, reality branches. Some versions end. One version hears a click, then another click, then another. From the outside, there is no mystery. From the inside, the mystery is almost unbearable. Because what the experiment seems to imply is not merely that survival can happen against staggering odds. It implies that there may be a private sense in which survival is the only thing you are ever allowed to notice. That is the thought at the center of this entire story. Not comforting, not beautiful, not uplifting, just severe. A branch-sensitive version of awareness following the path where it still exists, while every path where it does not becomes forever inaccessible. And once that possibility enters the room, even as a thought experiment, it becomes very difficult to think about death in the old, uncomplicated way again. This is the point where even people who take many worlds seriously begin to slow down. Not because the mathematics suddenly fails, not because the thought experiment becomes childish, but because the jump from branching physics to personal immortality is larger than it first appears, and many physicists are deeply unwilling to make it without resistance. That hesitation matters. It matters because quantum immortality has a seductive shape. Once you hear it, it seems to follow naturally. If all possible outcomes continue, and if consciousness can only occur where the brain remains functional, then it feels almost automatic to say. From the inside, you never reach your own non-existence. But feels automatic is not the same thing as settled. David Deutsch, one of the most influential defenders of the many worlds interpretation and one of the founding thinkers behind quantum computation, has long treated this issue with caution. Deutsch accepts branching. He accepts the reality of multiple outcomes within the universal wave function. But he has argued that quantum immortality requires an additional assumption, one that is easy to smuggle in without noticing. The assumption is that when reasoning about future outcomes, you should simply ignore the branches in which you are absent. That sounds innocent at first. Of course you are absent from branches where you are dead. Why count them from the first-person point of view? But Deutsch's concern is that this move may already be doing too much philosophical work. It may be converting a physical picture of branching into a highly selective rule about which future versions count as you. And once that rule is added, the conclusion starts to look less like pure physics and more like an interpretation layered on top of an interpretation. Sean Carroll, another major contemporary advocate of many worlds, is cautious in a different way. Carroll has often emphasized that future branches should not be thought of as one identical self, stretching smoothly through all outcomes. After branching, there are multiple future observers, each continuous with the person who existed before the split, but no longer numerically identical to one another in the simple everyday sense. That distinction sounds abstract until you apply it to survival. If one branch contains your death and another contains your survival, it is tempting to say that you survive. But Carroll's framing makes that sentence much less comfortable. A future surviving observer is not a magical rescue of the branch in which death occurred. It is another post-branch continuation. The fact that one future version remains alive does not erase what happened in the branch that ended. It does not retroactively convert death into safety. It only means reality contains multiple descendants, not one privileged thread guaranteed to win. And then there is Max Tegmark, the physicist most closely associated with giving the thought experiment its most famous modern form. Tegmark helped make quantum suicide impossible to ignore, but he has also been careful not to endorse the strongest possible conclusion people want to draw from it. His concern centers on measure, sometimes called branch weight. In many worlds, not all branches are treated equally when it comes to rational expectation. The Born rule, which links amplitudes to observed probabilities, implies that some outcomes carry vastly more weight than others. A branch where you survive against absurd odds may exist, but it may carry such a tiny measure that treating it as your rational expectation becomes difficult to justify. In other words, existence somewhere is not obviously the same thing as what you should expect to experience in the ordinary probabilistic sense. This is where the logic stops being cinematic and becomes technical. Quantum immortality is powerful as a story because it talks like certainty, but physicists are trained to distrust certainty when probability and identity are both involved. They know that the mind reaches too quickly for a clean line where the actual terrain is messy. Branching may be real, subjective experience may be branch-bound, but the step from those claims to, I should expect to live forever from the inside, is exactly the kind of step they hesitate to bless. So, the idea remains in a strange state. It is not universally accepted. It is not formally established. It is not something you can safely present as the settled implication of many worlds. And yet it refuses to disappear, because even its critics usually do not dismiss it as nonsense. They treat it as a dangerous overextension, an interpretive temptation, a conclusion that may be too fast or too literal or too dependent on hidden assumptions. But that is not the same as a clean demolition. It is more like a warning sign placed around a hole no one is entirely sure how to fill. That is why the thought remains so unsettling. If it were obviously foolish, physicists would not keep backing away from it so carefully. If it were obviously true, they would say so. Instead, it occupies a colder space than either of those. A possibility with enough structure to disturb serious people, but not enough consensus to let anyone rest comfortably inside it. And that uncertainty only makes the next implication darker. Because if quantum immortality is not a promise of endless survival, it may be something far less merciful. Immortality is usually sold as a fantasy of abundance. People imagine youth that does not fade, strength that does not decline, more time for love, more time for beauty, more time to finish what was left unfinished. The old myths are full of this hunger. Kings search for eternal life. Empires build monuments against decay. Modern laboratories promise longer health spans, slower aging, cleaner blood, better repair, more years added to the calendar. The assumption underneath all of it is simple and deeply human. More life must be better than less. But the version of immortality hiding inside this quantum idea is nothing like that. It is not a golden extension of ordinary life. It is not endless vitality. It is not waking up young in a brighter world where death has politely stepped aside. If the darkest reading of quantum immortality were true, the result would be much stranger and much crueler. You would not be preserved in perfection. You would simply continue along whatever branch still allowed continuation. And continuation is not the same thing as flourishing. That distinction matters more than it seems. Because the body does not fail all at once, at least not usually. It frays. It accumulates damage. It loses resilience in ways so gradual that the decline often hides inside routine until one day the routine itself has become smaller. A little less energy, a little more pain, a little more confusion, recovery taking longer, balance becoming less trustworthy, names taking longer to arrive, breath becoming shallower after ordinary effort, the world shrinking not in a dramatic collapse, but by inches. Now imagine that process not ending in the ordinary way. Imagine that in the overwhelming majority of branches it does. The heart stops, the cancer advances, the vessel ruptures, the infection overwhelms, the failing organ finally fails. The probabilities cash out in the familiar human direction, and the story reaches its natural edge. But in some vanishingly narrow branch, something else happens. The dangerous cell is caught. The clot dissolves. The artery holds. The fall misses the worst angle. The infection recedes. The weak heart survives one more night. Not because your body has become strong again, only because among the many physically allowed outcomes, there exists one in which the end is postponed. Then another postponement. Then another. This is where the romantic language around immortality breaks apart. Because what continues is not necessarily a better version of you. It may simply be the branch in which failure remains incomplete. The thread keeps going, but it grows thinner. The organism persists, but persistence is increasingly different from living well. Picture an old age more severe than the one people usually fear. Not cinematic, not grand, just narrowing. The room gets smaller because movement becomes harder. The body becomes more negotiated, more managed, more dependent. Sleep becomes fragmented. Pain becomes low and constant, the kind that no longer feels like an event because it has become part of the atmosphere. Memory starts to lose its smooth continuity. You know, there are names you once carried easily, faces once immediate, places once bright in detail, and now they arrive in pieces or not at all. Your own mind becomes less like a wide room and more like a hallway with dimmer lights. And still, the branch continues. This is the hidden terror in the idea. Quantum immortality, taken to its coldest limit, does not promise rescue from decline. It promises only that subjective experience may never cleanly reach zero. You do not leap into endless health. You remain attached to increasingly improbable survivals as the ordinary structure of life deteriorates around you. The best image for it is not a throne. It is a narrowing ledge. Each year, the common branches fall away. The ones where a typical human life ends at a typical human age become more numerous relative to the few where continuation still happens. The branch you occupy becomes more statistically bizarre, more fragile, more dependent on coincidences stacked on coincidences, molecular reprieves arriving in just the right order. You keep going, but into what? That question becomes even harsher when you stop thinking only about the body and start thinking about everyone else. Because if you continue through these improbable paths, other people do not automatically come with you. The people you love are following their own branching histories. your partner, your children, your friends, your parents, the handful of people whose voices have shaped the texture of your life. Each of them belongs to their own structure of outcomes. In branches where you persist, they may not. In branches where they continue, you may not. The survival of one observer does not guarantee the survival of another. So, the picture darkens again. Not only do you continue in rare branches, you may continue into increasing solitude. This is not the immortality of myth, where eternal life means eternal company, a perfected reunion, a banquet that never empties. This is a lonelier thing, a survival that can become statistically extreme and emotionally barren at the same time. The world keeps changing, generations pass, familiar voices disappear. Your inner continuity, already strained by aging and pain and cognitive dimming, is now asked to absorb absence after absence after absence. And even then, the question is not finished, because after enough change, what remains may no longer fit comfortably under the name you. Suppose the years continue far beyond what seems normal. Suppose medicine intervenes. Suppose technology keeps replacing failing functions one by one. Suppose memory becomes patchwork. Suppose personality shifts under pressure, under decline, under adaptation. Suppose the body that carries your awareness has been modified so extensively, repaired so often, and worn down so unevenly that the continuity feels legal rather than emotional, technical rather than human. Is that still you? The question sounds philosophical until you stay with it long enough. Then it becomes personal. Identity is easy to talk about when the self feels stable. It becomes much harder when continuity is the only thing left, connecting a distant future observer to the person who once moved easily through youth. If every cell has changed, every habit has altered, every relationship has ended, every memory has thinned, and every year has made the branch stranger, in what sense is the surviving awareness the same self that feared death in the first place? Maybe it is. Maybe identity is nothing more than unbroken continuation, however altered. But maybe not. Maybe the self is a pattern that can fray beyond recognition, while still remaining technically unfinished. Maybe the future observer is not exactly a preserved version of you, but an exhausted descendant of you, still conscious, still present, still somehow carrying the legal signature of a life, whose emotional substance has mostly evaporated. That possibility is more unsettling than ordinary mortality for a simple reason. Death, at least in the ordinary imagination, has a boundary. It is an edge. This darker form of immortality removes the edge and replaces it with asymptote. You approach the end more and more closely, while never quite arriving there in subjective terms. You fade toward nothing, without being granted the mercy of clean absence. Not forever in the storybook sense, forever in the mathematical sense. Continued existence in a path of ever lower probability, ever thinner branch weight, ever greater distortion from the life you once thought you were trying to preserve. This is why the idea, once it stops sounding clever, becomes almost unbearable. It turns humanity's oldest wish inside out. The ancient dream says, "Let me keep what I love and extend it." The quantum nightmare says, perhaps extension can happen without preservation. Perhaps consciousness can continue without comfort. Identity can continue without wholeness, and time can be added long after meaning has begun to thin. If that were true, immortality would not be a reward. It would be a kind of confinement, not a prison with walls you can point to, a prison made of persistence itself. A corridor in which the one thing denied to awareness is a clean disappearance, so that the branch continues not because it is beautiful, not because it is just, but because physics still permits one more improbable step. And once immortality stops looking like a blessing, the theory that first made this possibility thinkable begins to feel less like a triumph of science and more like the beginning of a tragedy. Long before his theory became famous, Hugh Everett III had the kind of mind that makes ordinary explanations feel insulting. He was born in 1930 in Washington, D.C., and by most accounts he was quiet early, self-contained, unusually mathematical, the kind of child who seemed less interested in belonging to the room than in understanding the structure behind it. Some people grow up socially fluent and emotionally legible. Everett seems to have grown in another direction. He was sharp, distant, difficult to distract, and already drawn to questions that most adults would have considered too large to answer cleanly. As a boy, he even wrote to Albert Einstein. That detail matters, not because it proves genius by itself, but because it reveals the scale of his attention. He was not content with local curiosities. He was interested in the deepest machinery. He wanted to know what reality was made of, what held it together, whether the universe at bottom was orderly or arbitrary. Einstein replied, and the exchange survived as one of those strange historical moments when a young mind, not yet fully formed, briefly touched one of the giants who had already changed the century. Everett carried that same intensity into adulthood. He studied chemical engineering first, then moved toward theoretical physics at Princeton, where the atmosphere around quantum mechanics was still charged with unresolved questions, even if many physicists had trained themselves to stop saying so out loud. The equations worked, the calculations worked, the experiments worked. But beneath all that success, the philosophical wound remained open. At Princeton, Everett entered a world shaped by major figures. John Archibald Wheeler was there, brilliant, imaginative, ambitious. Eugene Wigner was there too, with his own unsettling ideas about consciousness and measurement. Quantum mechanics was not a dead subject. It was a successful one, which is far more dangerous. Successful theories can hide their deepest problems behind their usefulness. People get paid, papers get published, technologies get built, and the unanswered question at the center is treated as a kind of impolite background noise. Everett was not the kind of person who could leave that noise alone. What bothered him was not that quantum mechanics failed to predict results. It was that the standard story about what those results meant seemed patched together. A system evolves smoothly according to the Schrödinger equation. It spreads into superpositions. Possibilities coexist. Then, suddenly, when a measurement happens, the story changes. One result becomes real. The wave function collapses. The observer is given a strangely privileged role, or the apparatus is, or the act of measurement itself becomes something half physical and half philosophical. A point where the equations seem to step back and let reality decide. To many physicists, this was tolerable. To Everett, it was ugly. He did not like exceptions. He did not like special pleading. He did not like rules that had to be added from the outside to rescue the feeling that the world is singular and definite. If the mathematics is fundamental, then it should apply universally, not to particles only, not to laboratory objects only, to everything. To instruments, to observers, to brains, to rooms, to worlds. That conviction seems to have sharpened one night in the mid-1950s during conversations at Princeton over drinks with other young physicists and visitors tied to the great quantum debates of the era. These were not ceremonial moments, no thunder, no revelation in a cathedral of science, just minds circling the same intolerable question. What if the wave function is not just a bookkeeping device? What if it is the actual physical description of reality? What if collapse is not a law of nature at all, but a human habit of interpretation? Everett followed that thought with unusual severity. Most people stop when an idea becomes socially dangerous. Everett kept going. If the wave function never collapses, then measurement does not erase possibilities. It correlates them. The observer becomes entangled with the system. In one branch of the total state, one outcome is seen. In another branch, another outcome is seen. No magical reduction, no outside intervention, no special status for consciousness. Just the same quantum law applying everywhere, all the time. He called it the relative state formulation. The phrase was technical, almost too mild for what it contained, because hidden inside it was a complete reorganization of how reality had to be imagined. Not one observed outcome made singular by collapse, but a branching structure of correlated states, Not one observer standing outside the system, but multiple post-measurement observers, each embedded in a different branch, each with a perfectly legitimate claim to the reality they experienced. This was not a small correction to Copenhagen. It was a refusal to accept its central compromise. Wheeler immediately saw both the brilliance and the danger. Everett's thesis was not the kind of thing the establishment could absorb easily. Niels Bohr's influence over quantum interpretation was immense, and Bohr's picture depended on the distinction between quantum description and classical measurement, between superposed possibilities and definite results. Everett's framework threatened that distinction at its root. If he was right, collapse was unnecessary. If collapse was unnecessary, one of the most psychologically comforting parts of the orthodox story might simply be wrong. Everett wrote the theory in full, with the confidence of someone who believed he had found not merely a new idea, but the cleaner version of an old one. His original manuscript was long, dense, mathematically serious, and radically unembarrassed by its own implications. Wheeler, acting partly as mentor and partly as political strategist, pressured him to soften it, tone down the provocation, cut the sections that would irritate Bohr and his circle, make it shorter, more diplomatic, more survivable. Everett resisted, but not enough to stop the trimming. The final thesis was reduced sharply. The language became more restrained. The edges were sanded where possible. Even so, the core remained explosive. When the thesis was examined at Princeton in 1957, Everett passed. The committee recognized mathematical ability, logical rigor, and intellectual force. On paper, he had succeeded, but the real trial was not the committee room. The real trial was whether the larger physics culture would treat the theory as an argument worth engaging. That is where Hugh Everett III began to become tragic, because everything about him seems to have made him both capable of producing the idea and poorly suited to navigating the world that received it. He was not warm, not diplomatic, not especially patient with ambiguity unless it was mathematical. He did not radiate the sort of personal style that reassures a threatened establishment. He was not building a school. He was not cultivating a movement. He was making a severe claim about reality and expecting the claim to survive on its merits. Sometimes that works. Often it does not. And yet, there was something almost heroic in the plainness of his commitment. Everett was not chasing mysticism. He was moving in the opposite direction. He wanted less magic, not more. Less collapse, less observer worship, less philosophical patchwork. He wanted a universe where the equations were allowed to mean exactly what they said. If that universe turned out to be stranger than ordinary intuition could bear, then the burden fell on intuition, not on the equations. That was the intellectual posture that made him unforgettable to those who later came to admire him. Not theatrical rebellion, not pseudo-profundity. A hard, nearly cold insistence that reality did not owe human beings a simpler metaphysics than the math allowed. And that is why he matters so much to this story. Quantum immortality, however speculative, however disputed, does not begin with fantasy. It begins with a young physicist who hated exceptions, distrusted collapse, and followed one question farther than most of his contemporaries were willing to go. He made the observer part of the system, let the wave function keep evolving, and in doing so opened a door that many people have wished had remained closed. By the time Hugh Everett's thesis arrived, quantum mechanics was not a fragile new theory waiting to be tested. It was already a triumph. That was precisely the problem. A theory that keeps winning experiments becomes harder to challenge, even when its foundations remain uneasy. The numbers worked, the predictions worked, the laboratories kept confirming what the equations said. So, for many physicists, the deeper question, what the equations actually meant, had become something close to bad manners. At the center of that world stood Niels Bohr. By the late 1950s, Bohr was not just an important physicist. He was an institution. His influence over the interpretation of quantum mechanics was enormous, not only because of his brilliance, but because he had helped define the language in which the subject was taught, argued, and socially enforced. The Copenhagen interpretation, associated above all with Bohr and Heisenberg, had become less a proposal than an atmosphere. Students absorbed it, departments repeated it, textbooks leaned on it, and the message, whether stated openly or not, was clear. Quantum mechanics is complete enough, collapse is part of the story, measurement marks the boundary, and anyone who insists on asking for a cleaner ontology is probably misunderstanding the point. Everett's theory was not dangerous because it failed. It was dangerous because it removed something the establishment had grown used to treating as necessary. If the wave function never collapses, then the familiar philosophical scaffolding around measurement starts to look optional. If the observer is just another physical system, then consciousness loses its privileged role. If all allowed outcomes remain inside the universal quantum state, then the single classical world of common sense becomes something emergent rather than fundamental. That was not a tweak. It was a rearrangement of authority. Wheeler understood this immediately. He admired Everett's work, but admiration was not the same thing as confidence that it could survive contact with Bohr's world. Wheeler had one foot in innovation and one foot in diplomacy. He knew that a young graduate student, however brilliant, did not simply stride into the capital of quantum orthodoxy and overturn its central assumptions by force of logic alone. Physics is made of equations, yes, but it is also made of reputations, loyalties, habits of thought, and invisible lines of permission. So, Wheeler tried to make Everett's work more survivable. He urged him to revise, to soften the tone, to cut the sections that directly challenged Copenhagen too sharply, to trim the full manuscript into something shorter, more tactful, less openly provocative. The original version had been expansive and uncompromising. The published version was leaner, more careful, more politically housebroken. Even the title became less threatening. The theory of the universal wave function gave way to relative state formulation of quantum mechanics, which sounded almost modest if you did not look too closely. Everett accepted some of this, but not happily. That tension matters because it shows the structure of the fight before the fight had fully begun. He was being asked, in effect, to make the truth easier for powerful people to tolerate, not to change the mathematics exactly, but to cushion the cultural impact, to act as though he were offering a technical variation when he knew he was proposing something much larger. Then came Copenhagen. Before Everett's thesis was formally published, Wheeler brought the work to Bohr's circle, hoping for engagement, or at least a hearing. What he met instead was something more chilling than technical criticism. He met dismissal. That word is important. Not refuted, dismissed. There is a difference between a theory being defeated and a theory being treated as though it does not deserve to enter the room in the first place. Defeat is almost honorable. It means the work was taken seriously enough to be attacked on its merits. Dismissal is colder. It is social. It says, this is not a threat because this is not worth understanding. Bohr himself seems to have regarded Everett's framework as unnecessary at best and misguided at worst. He did not see a need to replace the Copenhagen picture with a branching ontology. The standard interpretation already gave the correct answers. Why burden the theory with an infinity of effectively parallel realities when ordinary practice worked perfectly well? For Everett, that response would have been infuriating because it missed the point. He was not adding baggage. He believed he was removing it. Collapse was the extra machinery. The special role of measurement was the awkward patch. Many worlds was not excess in his mind. It was what remained when you stopped protecting intuition from the full implications of the equations. But Bohr's circle did not meet the idea halfway. Accounts from the period suggest not a calm technical debate, but a combination of impatience, resistance, and near complete unwillingness to grant Everett's framing the seriousness it demanded. Leon Rosenfeld, one of Bohr's fiercest defenders, later wrote about Everett with an extraordinary contempt, attacking not only the theory, but the man. That kind of reaction tells you something about the intellectual climate. When mathematics alone is not enough to keep people secure, tone sharpens. The defense of orthodoxy becomes personal. Everett eventually traveled to Copenhagen himself. It did not go well. By then, the emotional shape of the conflict was already fixed. On one side stood the old center of quantum authority, accomplished, confident, culturally dominant, and largely uninterested in reopening questions it believed had already been dealt with. On the other stood a young theorist with a radical idea, too mathematically serious to dismiss as nonsense, but too philosophically disruptive to welcome comfortably. The encounter changed little. Bohr did not embrace the theory. He did not dramatically refute it either. He simply remained Bohr, unconvinced, immovable, and surrounded by a culture in which his way of thinking had become nearly self-validating. Everett left without the kind of engagement he had hoped for. Later, he summarized the whole experience with a bitterness that sounds earned. He understood, perhaps more clearly than before, that he was not losing a fair technical contest. He was colliding with an empire, and empires do not always defeat heresy by argument. Sometimes they defeat it by starving it of oxygen. That is more or less what happened. Everett's thesis appeared in print in 1957, alongside a companion piece by Wheeler, meant to make it easier for the community to digest. The response was thin. No great wave of serious debate followed. No immediate revolution. No welcoming cohort of senior physicists eager to explore the consequences. There was instead a kind of professional shrug, which may be the most effective form of rejection science possesses. A bad idea can be attacked. A threatening idea can be marginalized. But an idea treated with silence enters a different kind of exile. It survives in the literature, but not in the bloodstream of the field. It becomes something people could read, but do not. Something cited occasionally, but not inhabited. Something available and absent at the same time. For Everett, the result was devastating in a very specific way. He had not been proven wrong. He had been denied the dignity of full opposition. His theory was too serious to laugh away entirely, but not sufficiently acceptable to become part of the official future. He had produced a new way to think about reality, and found that the culture of physics preferred not to think about it at all. That wound stayed with him. Because the cost of this war was not only theoretical, it pushed him out. The combination of institutional chill, career pressure, military-era practical concerns, and a field unwilling to reward his kind of stubborn clarity helped drive him away from academic physics before he had really begun. He moved instead into defense work, into nuclear strategy, into a life where his mathematical gifts would still be used, but not in the service of the question that had once mattered most to him. The irony is almost unbearable. The man who denied collapse was himself collapsed socially, compressed by hierarchy, orthodoxy, and indifference into a figure the discipline could postpone dealing with. His theory would survive. It would return. It would eventually grow stronger than the people who tried to bury it. But at the time, whatever it experienced was not triumph. It was erasure. What happened next did not look like the life of a man preparing to reshape reality. It looked, from the outside, like withdrawal. Hugh Everett did not stay in academic physics and build a school around his theory. He did not spend the next 20 years refining it in journals, defending it at conferences, or gathering a generation of students around the idea that the wave function never collapses. Instead, he moved into defense work. He went into military analysis, nuclear strategy, systems evaluation, the mathematics of survival and catastrophe measured at the scale of governments. There is something almost unbearable about that turn. The man who had imagined a universe in which every quantum possibility continues went to work in a world where probabilities were being used to calculate how millions of people might not. He was good at it. By all accounts, very good. His mind was still powerful, still fast, still severe in the way that had always made him exceptional. But whatever had made him capable of seeing further than most people in theoretical physics did not make him easy to live with. If anything, it seems to have deepened the distance between him and ordinary life. He married, he had children, a family formed around him. From a distance, it could have looked stable enough, a respectable career, a house, a future. But inside the household, the atmosphere was different. Everett was often described not as violent or theatrical, but as absent in a more difficult way. Physically present, emotionally unreachable, enclosed inside a private weather no one else could enter. He drank heavily, he smoked constantly, he gained weight. He did not care for his health in any ordinary sense. He distrusted doctors and avoided medical care. The body, which to most people is a fragile companion requiring maintenance and humility, seems to have meant something colder to him. He treated it less like a shared life and more like a temporary mechanism, useful but not sacred. That detail matters because ideas do not always remain on paper. A theory can begin as mathematics and still leak into temperament. It can become a private lens through which the body looks less final, death less absolute, health less urgent. We cannot know every thought Hugh Everett carried in silence, but enough survives from biographies, family recollections, and later accounts to suggest that he did not treat mortality the way most people do. He seems to have believed, at least to some degree, that consciousness was not simply extinguished by the ending of one branch, that if reality truly split, awareness would continue along whatever line remained open. If a person starts to feel that way deeply enough, self-preservation can begin to look optional. His son, Mark Oliver Everett, who would later become known as the musician E, described a father who felt almost ghost-like even while alive, a man at the table, a man smoking, drinking, sitting, thinking, but rarely opening into the warm, ordinary exchanges that make family life feel inhabited. Not much affection, not much emotional access, not much of the softness children use to locate themselves inside love. This is one of the cruelest ironies in the whole story. Hugh Everett created a theory in which observers branch into multiple futures. Yet inside his own home, he often seems to have existed as though other inner worlds were inaccessible even in a single kitchen, a single evening, a single room. The universe may have contained countless versions of reality, but the versions that mattered most to his children were the ones in which their father remained distant. His daughter, Elizabeth, suffered deeply for many years. Her life was marked by severe mental illness, repeated crises, and visible pain inside a family that already lacked emotional steadiness. It would be wrong to reduce her suffering to one cause. Human distress is rarely that simple. But in the Everett household, the theory was not just a theorem. It was part of the psychological air. It existed nearby as a set of possibilities about consciousness, continuation, and what death might or might not mean. That is where the story becomes heavier than physics. Because once an idea enters family life, once it mixes with loneliness, silence, illness, and the human hunger to believe that separation is not final, it stops behaving like a neutral abstraction. It begins to acquire weight. It begins to lean on people. It begins to offer dangerous comfort in moments when comfort is already unstable. Everett himself died in 1982, only 51 years old, of a heart attack after years of smoking, drinking, and neglecting his health. The end was not mysterious. It was the sort of ending his habits had been moving toward for a long time. But even here, the emotional logic of his life and theory seemed to meet in a way that is difficult to ignore. He had reportedly said he wanted his ashes thrown in the trash. No grand memorial, no sacred treatment of remains. If consciousness continued elsewhere, the body left behind was only residue. His family did not simply move on from that. His daughter would later die after a long and painful struggle with mental illness. Her loss cast an even darker shadow backward over everything that had come before. The theory that once seemed like a brilliant act of intellectual defiance now sat in the same emotional field as grief, illness, distance, and irreversible human damage. It is not that the mathematics caused the tragedy. That would be too simple and too unfair. But the family story makes something painfully clear. Ideas about death and continuation do not remain harmless when they enter fragile minds and wounded homes. This is why the Everett story resists clean admiration. His theory may have been profound, his insight may have been real, his influence may have arrived late but decisively. And still, the human cost sits there. A father who withdrew, a household shaped by absence, a family carrying pain that could not be solved by brilliance, a theory about branching consciousness lingering nearby like an unanswered whisper. That is the part many summaries leave out. They tell you about Princeton, about Bohr, about many worlds, about delayed recognition and eventual vindication. All of that matters, but this matters too. The people nearest to Hugh Everett did not live inside an elegant interpretation of quantum mechanics. They lived inside the emotional weather of a man who seemed, in some essential way, already elsewhere. And when a theory begins to cast shadows inside a family, it becomes impossible to keep pretending that physics is only about equations. At the center of all of this sits an experiment so simple that it almost feels insulting. Two narrow slits cut into a barrier, a screen behind them, a source of light in front, no grand machine, no cosmic scale, no black holes, no exotic mathematics written across a board, just light, a wall, two openings, and the question that has been quietly tearing at physics for more than 2 centuries. What is reality doing when no one is looking? The experiment first appeared in the early 1800s, when Thomas Young used it to settle a fight about the nature of light. If light were made of tiny particles, like little bullets, then sending it through 2 slits should produce 2 bright bands on the screen behind them. 1 slit, 1 band. 2 slits, 2 bands. But that is not what appeared. What appeared was an interference pattern, alternating bright and dark stripes, the unmistakable signature of wave behavior. Waves overlap. Their peaks reinforce each other. Their troughs cancel each other out. The screen was showing not 2 simple tracks, but a ripple pattern, as if the light had passed through both slits and interfered with itself. For a while, that seemed to settle it. Light was a wave. Then the 20th century arrived and destroyed the comfort of that answer. Einstein explained the photoelectric effect by treating light not as a smooth wave, but as discrete packets of energy, photons, particles. And now, physics had a problem. Young's experiment said wave. Einstein's work said particle. Both were right, both were confirmed. Reality refused to stay in one category. That would already be strange enough. But the experiment becomes much worse when you run it 1 particle at a time. Imagine emitting a single photon toward the slits. It hits the screen as a single point. 1 event, 1 tiny dot. Do it again. Another dot, again, again. At first it looks random, like grains of dust landing where they may. But keep going long enough and the dots do not form 2 simple piles. They slowly build the same interference pattern. This is where the mind begins to resist. There was only 1 photon in the apparatus at a time. It had nothing else to interfere with. No neighboring wave, no crowd, no beam. And yet the final pattern is the one you would expect if something had gone through both slits at once and interfered with itself before arriving. That is not a metaphor. That is the result. So naturally someone asks the next question. Fine. Which slit did the photon actually go through? And the moment you try to answer that, the pattern changes. Place a detector at one of the slits, or at both, something capable of recording the path. Fire the photons again. Now the interference pattern disappears. Instead of a wave-like series of bright and dark bands, you get something much more ordinary. 2 clumps, 2 tracks, behavior much closer to particles choosing one route or the other. The act of determining the path destroys the pattern. That simple fact is the wound around which modern quantum interpretation grew, because it seems to imply something almost intolerable. When you do not ask which path the photon took, reality behaves as though both paths matter. When you do ask, it behaves as though one path was selected. Observation does not merely reveal the state of the world. It seems to participate in what kind of world shows up. Bohr built much of his interpretive vision around this discomfort. The photon, in the Copenhagen picture, is not secretly a little ball choosing 1 slit while pretending to be a wave, nor is it literally a classical wave in the old intuitive sense. It exists in a quantum superposition, a structure of possible outcomes described by the wave function. When measurement occurs, that superposition collapses into one definite result. That was the official answer, but it leaves behind an ache. What counts as a measurement? Why should measurement be special? At what point does the smooth evolution of the wave function stop and the definite world begin? Those questions get even sharper with Schrödinger's cat. Place a cat in a sealed box with a device tied to a quantum event. If the event goes one way, the cat lives. If it goes the other, the cat dies. Under a naive reading of the formalism, before the box is opened, the whole system is in a superposition. Living cat and dead cat entangled with different possible outcomes of the microscopic event. Schrödinger proposed the scenario to expose what he saw as the absurdity of the standard picture. But the absurdity did not go away. It just moved. If you say the cat is already definitely alive or dead inside the box, then you must explain when and how that definiteness emerged. If you say collapse happened because the cat itself functioned as an observer, you have only pushed the mystery inward. If you say the apparatus did it, you still have not said why apparatuses get to break the rules that everything else obeys. This is exactly where Everett's idea begins to feel less like science fiction and more like a brutal kind of consistency. He looked at the same experiment and refused the special exception: no collapse. No privileged moment where possibilities are erased and one reality becomes official. The wave function keeps evolving. The photon goes through both available paths in the quantum description. When detectors are added, they become entangled with the photon. When an observer reads the detector, the observer becomes entangled too. What looks like a single outcome from inside one branch is, from the larger view, a separation of branches through entanglement and decoherence. That last word matters: decoherence. Decoherence is the process by which quantum superpositions become entangled with their environment so thoroughly that the different branches stop interfering in any practically recoverable way. The world starts to look classical, not because collapse has magically selected one reality, but because the alternatives have become effectively isolated from each other. The interference is lost, not by metaphysical decree, but by physical interaction with everything around the system. That is why this experiment is the one you cannot escape. Quantum immortality is not a random fantasy attached to physics from the outside. It grows from the same place as the double slit problem, the same place as Schrödinger's cat, the same place as the measurement problem itself. If collapse is real, then the world narrows into one outcome. If collapse is not real, then branching becomes unavoidable. And once branching becomes unavoidable, the question stops being whether reality is strange. The question becomes how strange you are willing to let it be. At any given second, your brain is doing something so complicated that even describing it in ordinary language feels slightly dishonest. Neurons are firing or staying quiet. Ions are crossing microscopic channels in cell membranes. Neurotransmitters are being released, reabsorbed, withheld. Proteins are changing shape. Electrical gradients are shifting. Signals are racing across networks built from roughly 86 billion neurons, each one connected to thousands of others. You experience this as a thought, a hesitation, a memory, a feeling, a sentence forming in the dark. But underneath that sentence is machinery, and underneath that machinery is physics. This matters because many worlds does not wait for dramatic moments. It does not care whether you are making a life-changing decision or absent-mindedly reaching for a glass of water. Branching is not reserved for crossroads. It happens wherever quantum outcomes matter, even a little. That means the structure of divergence is not built only from weddings, wars, and career choices. It is built from events far smaller than the self usually notices. A calcium ion moves one way rather than another. A vesicle releases its contents now rather than a fraction of a second later. A neuron reaches threshold in one branch and misses it in another. A pattern of activation tilts slightly left instead of slightly right. The brain is warm, wet, noisy, and not a quantum computer in the popular science fiction sense. Most quantum coherence is destroyed almost immediately in such an environment. But that does not rescue us from branching. decoherence is not the absence of quantum effects. It is the process by which quantum alternatives become effectively separate. In a many-worlds picture, that is exactly how branching becomes the ordinary hidden background of reality. So, each moment of awareness sits on a floor that is far stranger than it feels. You do not experience yourself as splitting, you experience yourself as continuous. That continuity is what gives personal identity its emotional force. You remember childhood, or at least parts of it. You remember your own face at younger ages. You remember mistakes, places, voices, losses, ordinary afternoons. The mind binds these fragments into a narrative and says, "This is me, one person, one thread, one life." Many Worlds does not completely destroy that feeling. It does something more unsettling. It localizes it. From inside any one branch, you still feel singular. Your memories still line up. Your point of view still feels exclusive. The problem is that other versions of you can say exactly the same thing, with equal legitimacy. They too possess continuity. They too remember being the child you remember being. They too believe themselves to be the authentic center of the story. There is no master copy. That may be the most difficult sentence in this entire subject. No privilege you sits above the branches like an owner overseeing lesser duplicates. No original continues while the others are merely shadows. If branching is real, then every post-branch observer has the same claim to authenticity from the inside. The difference between you and a nearby version of you may be microscopic at first. One neuron firing earlier, one phrase spoken differently, one glance held longer than expected. But each of those tiny differences can accumulate. Over time, the divergence widens. Different moods become different choices. Different choices become different histories. Different histories become different selves. And all of them remember beginning as you. This is where the theory stops being only about physics and starts cutting into the structure of the self. Consider a decision that feels important, whether to leave, whether to stay, whether to call someone back, whether to forgive, to confess, to wait, to step into the room, to keep driving, to turn around. In ordinary life, we imagine one decision becoming real while all other possibilities fade into the category of what might have been. That category matters emotionally because it contains regret, the unlived life, the road not taken. Many Worlds alters the emotional geometry of that idea. The road not taken may not vanish. It may be taken elsewhere, not by a stranger, by another continuation of you. That sounds at first almost comforting. It is not, because the same logic that preserves the missed opportunity also preserves the terrible one. The version who said yes, the version who said no, the version who survived, the version who did not, the version who became kinder, the version who became crueler, the version who drifted into a different life so gradually that no single day felt decisive, only the accumulation of tiny branch-sensitive moments beneath awareness. Every version thinks it is the real one. Every version is right, and this forces an ugly question onto free will. What does it mean to choose if all allowed outcomes are realized somewhere? If there is a branch in which you took the job, and another in which you refused it, one in which you married and one in which you did not, one in which you spoke and one in which you stayed silent, then what exactly was the choice? Did you select one path from many? Or did reality distribute your possible futures across multiple descendants and let each one inhabit a different answer? Some people hear that and conclude that freedom has been erased. If every possible outcome happens, then no single act seems special enough to deserve the name decision. The universe branches and choice becomes just what one local observer calls the branch they happen to occupy. Others hear the same thing and move in the opposite direction. They say many worlds does not eliminate could have done otherwise. It multiplies it. Under strict determinism, only one future exists, and every feeling of openness is, in the end, illusory. Under many worlds, more than one future really does unfold. You did do otherwise, just not within one single line of history. That answer solves one problem by making another one worse. Because now the word you is unstable. Does you mean this present stream of awareness, the one hearing this sentence right now, this one narrow tunnel of memory and sensation? Or does you mean the full branching family of selves radiating outward from your present condition, all equally descended, all equally real, all increasingly different with time? The first version preserves intimacy, the second preserves structure. Neither is easy to live with, and perhaps that is the point. Many worlds takes the self, which already feels mysterious from the inside, and removes the last illusion that it must be singular at the deepest level. What you call identity may be less like a point and more like a branching pattern, less like a line and more like a tree whose limbs no branch can fully see from within. So, when we say that every version of you is real, that is not poetry. It is not motivational language. It is not a metaphor for possibility. It is the direct emotional consequence of taking branching seriously. Reality does not owe you a single biography just because consciousness prefers one. It may be giving you many, and the only reason this one feels complete is that it is the only one you can currently remember. There is a point in this story where the idea stops sounding like philosophy and starts sounding like arithmetic. Not comforting arithmetic, not the kind that clarifies a household budget or measures the distance between cities. The kind that makes human intuition feel tiny and provincial. The kind that takes an event you call impossible and quietly replies, impossible is not the same thing as zero. That difference is doing almost all the work. If many worlds is true, then every quantum event with more than one allowed outcome produces a branching structure. Not metaphorically, not in the loose science fiction sense, formally. A superposition evolves, decoherence separates alternatives. Distinct branches emerge. The universe does not select one future and destroy the others. It carries all the non-zero possibilities forward. That last phrase matters more than it seems. Non-zero. A non-zero probability does not mean likely. It does not mean common. It does not mean humanly reasonable. It only means permitted. And once something is permitted inside a branching universe, it exists somewhere in the total wave function, however tiny its measure may be relative to the more ordinary outcomes. We are used to thinking in one-world terms, where the practical difference between extremely unlikely and effectively impossible is often good enough. If the odds of something are 1 in a trillion, most people compress that into the same emotional category as never. But the many worlds picture does not let you make that compression so easily. If an outcome is not forbidden, then it is not erased. It becomes part of reality's full spread. A simple example helps. Flip a fair coin once and there are 2 obvious outcomes, heads or tails. Flip it 10 times and the possible sequences multiply quickly. In ordinary life, you expect a mix, some heads, some tails, a distribution that feels normal. Getting heads 10 times in a row is unlikely, but still imaginable. Push it to 100 flips, and a run of 100 heads feels absurd. The probability is so small that common sense stops treating it as a live possibility. But under a branching picture, after 100 flips, all 100 flip sequences exist somewhere. The ordinary ones dominate your intuition because they dominate the distribution. But the extreme ones are not excluded. They are there too, thin and strange and difficult to emotionally accept, but real in the only sense the theory ultimately cares about. Now replace coins with survival. At every moment, your body is threaded through events that could go more than one way: repair or failure, detection or miss, recovery or collapse. Most of the time, the ordinary statistical flow carries human life toward its familiar end. Aging accumulates, damage accumulates. The body becomes less resilient. Typical branches terminate at typical times. Nothing about that is controversial. The unsettling part begins when you ask what happens to the atypical branches. If there exists a branch where the dangerous mutation is corrected, where the vessel holds, where the infection recedes, where the accident misses the lethal angle, where one more improbable rescue occurs, then that branch is not nothing. It is part of the real branching structure. Its measure may be tiny, its weight may be vanishing compared to the central mass of more ordinary outcomes. But tiny is not zero. And if awareness can only be present where the physical substrate supporting awareness still functions, then the logic begins to tighten. This is why quantum immortality does not vanish simply because it sounds outrageous. It is attached to a very stubborn mathematical skeleton. Strip the idea down to its bare bones, and it rests on only a few premises. First, many worlds must be broadly correct. The wave function must not collapse. Quantum alternatives must continue as branches rather than being reduced to one official outcome. Second, consciousness must depend on a functioning physical system. No brain, no awareness, no mystical transfer, no ghost stepping outside the formalism. Just physical continuity where the relevant structure remains intact. Third, branching must apply universally, not only in toy laboratory cases. The same underlying quantum rules must matter everywhere matter matters, including in the chemistry and instability of living bodies. If you grant those three premises, the conclusion becomes difficult to dismiss with a wave of the hand. Not proven in every philosophical detail, not cleanly settled, but difficult to dismiss. This is why the idea has stayed alive, even among people who dislike it. Of course, there are objections. One of the most famous is the preferred basis problem. If the universal wave function contained many possible ways of being decomposed mathematically, what determines the actual branches we talk about? Why these worlds rather than some other arbitrary slicing of the total state? The modern response points to decoherence. Environmental interactions select stable, effectively classical structures, the so-called pointer states, that survive long enough to behave like the branches we observe. In other words, the branches are not chosen by whim. They are shaped by the physics of entanglement and environmental monitoring. Then there is the born rule problem. If all outcomes occur, what exactly does probability mean? In a single world theory, probability tells you which result will happen. In many worlds, everything with non-zero amplitude happens somewhere. So, probability must mean something subtler, a weighting over future branches, not a yes or no existence claim. That is why thinkers like Deutsch and David Wallace try to derive rational expectation from decision theory inside a branching universe. Their arguments are not universally accepted, but they are serious, and they show how far the interpretation has come from being a fringe curiosity. That matters too. Many worlds is no longer just the abandoned provocation of a young theorist at Princeton. It has become one of the major live options in quantum foundations. Not because it is emotionally easy, not because it flatters common sense, but because it removes collapse, keeps the mathematics uniform, and aligns naturally with decoherence in a way many physicists find hard to ignore. And that leaves the idea of quantum immortality in its strange, uncomfortable place. Not established doctrine, not a crackpot fantasy, not a conclusion everyone accepts, not a conclusion everyone can kill, which is exactly why it continues to haunt the edges of serious thought. The mathematics does not force you to love the implication. It does not even force you to endorse it. But it does something almost as unnerving. It refuses to let the implication disappear completely. And once you have followed the logic this far, the final question no longer feels abstract. It becomes intimate, because eventually all of this stops being about branches in the formal sense and turns into one softer, stranger mystery. What exactly happens when awareness reaches its edge? There is one final question that physics can approach, but not fully own. What happens when awareness reaches its edge? You have fallen asleep thousands of times. You have lost consciousness under exhaustion, illness, or anesthesia. And yet those experiences are strange because they are not really experiences in the ordinary sense. You do not watch yourself disappear moment by moment. You close your eyes, and then, somehow, there is a later moment, a gap, an absence, a missing stretch of lived time that your mind quietly stitches together after the fact. That alone should make us humble. Because even before we speak about death, consciousness is already mysterious. We know it depends on the brain in powerful ways. Damage the brain and awareness changes. Alter the chemistry and the self changes. Interrupt the activity and the stream of experience seems to thin or vanish. But knowing that consciousness is deeply tied to matter is not the same thing as understanding what consciousness is. And that leaves us with 4 possibilities. The first is the old severe answer. Under a collapse-based view of reality, death is final. The brain ceases to function. The physical system that generated awareness comes apart. The story ends. There is no branching refuge, no private corridor, no surviving first-person thread. The last close of the eyes is simply the last one. The second possibility keeps many worlds but removes its most unsettling promise. Branching is real. Multiple outcomes continue. But the version of you experiencing this moment is not somehow rescued by the mere fact that another branch contains another observer descended from you. In that picture, there are future continuations and future endings, but no magical guarantee that this particular stream of subjectivity slips around every wall forever. Other branches survive. This one still reaches its limit. The third possibility is the one that haunts people, full quantum immortality. The idea that you never encounter your own non-existence because awareness can only ever be present where awareness still functions. Branches end elsewhere, but from the inside, there is always some narrowing path forward. Never perfect safety, never eternal youth, only continuation without clean extinction. And then there is the fourth possibility, which may be the most honest. Physics may not yet know enough about consciousness to settle any of this. The equations of quantum mechanics describe amplitudes, measurements, interactions, probabilities, entanglement. They do that with astonishing success. But nowhere in the formalism is there a variable labeled feeling, or being, or the redness of red, or the inward fact that experience exists at all. Physics describes structure beautifully. It does not yet explain why structure should ever be accompanied by subjectivity. If that missing piece is large enough, then asking what happens at the boundary of awareness may not be a question physics can answer by itself. So, we arrive at a strange kind of honesty. Quantum mechanics may change how we think about death. Many worlds may change how we think about endings, but neither gives us full possession of the mystery. And perhaps that is why this subject lingers, not because it proves immortality, not because it proves oblivion, but because it reveals how little we really understand about the one thing through which every theory is known in the first place. Consciousness, the quiet fact that you are here, now, hearing these words from the inside. That remains the deepest strangeness of all. And so, after all of this, we arrive back at the strangest fact of all. You are here, not in the abstract sense, not as a philosophical placeholder. You are here in this moment, inside this branch of reality, aware enough to listen, aware enough to wonder, aware enough to feel the weight of a question that physics still cannot fully close. Maybe the universe really does branch without end. Maybe there are other versions of tonight, unfolding in ways you will never see. Maybe consciousness rides a narrower path than we understand. Or maybe the truth is simpler, harsher, and quieter than that. But whatever the final answer turns out to be, one thing remains astonishing. Matter became awareness. A universe of particles and fields, of stars and empty space, produce something that can ask what it is, why it is here, and what happens when it is gone. That may be the deepest mystery in this entire story. Deeper than many worlds, deeper than death, deeper even than the mathematics that led us here. Because before any theory can be known, there must be someone to know it. And tonight, that someone was you. So, if this journey stayed with you, if you enjoyed drifting with me through quantum physics, consciousness, and the stranger edges of reality, take a moment to like the video, subscribe to the channel, and leave a comment below telling me what you'd like to explore next. Your ideas genuinely help shape where these nighttime journeys go. And for now, let the questions loosen a little. You do not have to solve the universe tonight. You do not have to settle the fate of consciousness before sleep. You only have to be here for this one quiet moment, in this one room, in this one version of the night. Thank you for listening, thank you for staying, and thank you for being the version of yourself that made it all the way to the end. Sleep well, and try not to think too hard about how many other versions of you may be closing their eyes at the very same time.